Everyone. So today we are going to discuss about the second part of the topic, that is evolutionary forces that affect allelic frequency. The second part we will be dealing with migration and natural selection. So migration means to travel or to move from one place to the other. But migration in terms of evolution means the travel or the movement of the genetic information from one population to the other. That means migration, also known as gene flow, as there will be flow of the genetic information from one individual of that population or group of individual of that population. The genetic material is carried from one population to another. So there will be gene flow, which includes the different kinds of events. Okay, like pollen grains are blown to a new destination, new place, new cities. So practically, if we think whatever mutation it is or genetic drift it is, but if there is no migration, no flow, then how the character will be there? So migration is very important. Okay, very important for evolution to be successful. Because of the migration, there will be flow from one population to the other. So it is a very important evolutionary force which leads to the dynamic property of the evolution. As we are saying, our evolution is dynamic, it is not static. What makes it dynamic? The flow of the information, flow of the genetic information from population to population, from generation to generation. It is because of migration. So if gene versions will be carried from population, so definitely there will be variations. Okay, from one population to the other, when there will be carried of, or there will be movement of the information, there will be genetic variation. And migration, selection, they will work together for diversity, but in a opposite way. How? So if selection will be stronger than migration, okay, if selection will be stronger than migration, then there will be more diversity. That means, suppose in a population that their characters are migrating, but in that case our selection is more or faster than the migration, then it will be more diversity, because selection will lead to diversity, more variety will be produced. If it is not selected, it will be eliminated. So that is why more the selection, more will be the diversity. If migration is stronger, that means there will be more more flow than the selection, then there will be less diversity. Okay, so this is how migration will work together. So this is the diagrammatic representation of how our gene flow is happening. So if we talk of population, there will be barrier, there will be geographical barrier, there will be environmental barrier. So always there will be a barrier. And in evolution, they have to cross that barrier to be successful, to be the survival. So they have to cross the barrier to for the successful flow of the information. So as we can see in this diagram, we have population 1, we have population 2, and the barrier is a geographical barrier, that is mountain range. So in from population 1, two alleles were successful in transforming from population 1 to population 2. Okay, so those that will transfer, those that migrated, the two alleles, they are the gene flow. In that allele, the character got transferred, they are the gene flow is there from one population to the other. So migration is explained with the help of a model. That model is known as one island model. Okay. So migration, if so in migration we have one mainland and one small island. Okay, the mainland and the island, they are far. It is not that they are connected, they will be far apart from each other. And it is definitely true, if they're far apart there will be barriers. So in spite of that barriers, if if some if some alleles will get transferred. Now imagine from mainland, which is a very big land. Okay, if 4 5 alleles will move or transfer to the small island, how does will it affect to mainland? Nothing. But already in island there will be very few, small land there will be very few. Okay, from that if 2 3 alleles will flow to the mainland, definitely that will affect to the allelic frequency of the island. Okay, so migration, if it is from small population to large population, it won't create any difference for the large population. But if the reverse, from large to small, definitely it will help in variation, because already it is small, variety will be less, and small population is good for breeding. So if some allele will transfer from mainland to the small island, definitely there will be more variation, it will help in the variation. So this example or this study hypothesis, the hypothesis that if migration will be from small population to large population, it won't create any effect. But if it is from large to small, definitely this will help in variation. This hypothesis was proved with the help of a model that is known as one island model. Okay, so this is a hypothetical proof. Okay, proof, the model hypothetical proof. Now migration causes evolution. How? Because migration can cause allelic frequency to change from one generation to the other. So as our generation will change from one generation to other, so definitely there will be migration, and this will violate Hardy-Wegner principle, because Hardy-Wegner said that there will be no migration, no mutation. But ideally, in a dynamic population, there is migration. And if there is migration, definitely it will cause allelic frequency change for both the population from which it has migrated to which it has migrated. Okay, both the allelic frequency will change. And change in allelic frequency will be violation of the Hardy-Wegner principle. And if they are migrating, if there is allelic frequency change, means there will be evolution. Migration is a very powerful mechanism of evolution. So whatever change, whatever mutational variation, whatever variation will be there, if it is not transferred, if there is no flow of the information, what will be the use? So migration is a very powerful mechanism of evolution. Without migration, there will not be a successful evolution. For the evolution to be successful, genetic information must flow from one population to the other. Our next evolutionary force is natural selection. You have selection in broader terms, that is our each and every types, everything is there in detailed form. Here we will discuss how natural selection is helping in evolution, as the types of selection is already in the, we will be discussing in another topic, types of selection. All the types of selections are separately mentioned in the next topic. So natural selection, here only natural selection. Selection can be two types: artificial selection, natural selection. Natural selection was the term, okay, first time it was used by Charles Darwin. He was the one who used the term natural selection as a evolutionary force. but his concept was applicable to individual. Darwin did not talk of natural selection with respect to population. How natural selection is affecting a population, Darwin didn't talk of. Darwin talked of natural selection with respect to origin of species, with respect to individuals, not of population. But currently, if we discuss, currently natural selection is considered as the phenomena of differential and non-random reproduction of divergent genotypes divergent in a population. It is a non-random process. Natural selection is not random, it is a non-random process, and it is differential, which will give rise to diverse genotypes in a population. So it is a force which will maintain or which will contribute as it is creating divergent and genotypes. So definitely it will contribute to various genotypes or the flow of genotypes to the next generation. The genotypes which nature will select or which nature will want to have, it will be selected, and that particular genotypes will flow from one generation to the next generation, and definitely it will create the variation. So natural selection encourage beneficial gene. So definitely when nature will select, it will want the fittest one, the better one, the beneficial one, which will help the nature. So natural selection will affect or help in the encouragement of beneficial gene. They will help in the differential reproduction. Natural selection is the differential reproduction of genotypes in a population. That is, it brings about differential contribution of offspring to the next generation. It means what is that the individuals that are best adapted to the environment, the individual which will be best adapted to the environment will reproduce at a higher rate and produce more offspring than the one which will be less adapted. Better adaptation, better reproduction. So this contributes to the greater percentage of genes to the gene pool in the subsequent generation. That is your differential reproduction, which is dependent on adaptation. Better adaptation, better reproduction. And beneficial gene. So selection will definitely encourage the gene which have highest adaptability efficiency. The better the adaptation efficiency, the better contribution to the nature. So definitely nature will encourage such beneficial gene. It will favor that, okay, which will be better adapted to the environment, so that they can, such gene will definitely contribute to the better. Now, how our natural selection works? Okay, so the working of natural selection is very complex because it acts at all the levels of organization, at all the level, from the cellular level to the molecular level, at all the level of the organization and organism, natural selection works. Okay, and upon all the stages of the life cycle of the organism, if you imagine any stage of the life cycle, natural selection will be there. So it is a very complex process, as it is having, it has to work at all the level. So working of the natural selection is discussed under the two broad heading. One is selection of for single gene traits, and one is selection for multi-gene traits. Selection for single gene traits means is that the natural selection operates for traits determined by a single gene pair. Okay, the traits or the characters which are determined by a single gene pair are selected by the natural selection, and the natural selection may be against the dominant, may be against the recessive, or it can be against the homozygous or the heterozygous. So for this, for the study of single gene traits, there are certain terms like we have is survival rate, relative fitness, selection coefficient. Survival rate means survival rate of each genotype is defined as the rate. Rate means with respect to time. Okay, so rate of each genotype is defined as the fraction of that genotype that contributes to the next generation is known as survival rate. Relative fitness of each genotype is the survival rate. Survival rate expressed as the fraction of maximum survival rate. Okay, that means what you are surviving at the maximum level, that is your fitness, how fit you are in the nature. So these are discussed under the four headings, that is selection against dominant alleles. Selection against dominant alleles means against means it is for recessive alleles. So selection against dominant genotypes leads to the elimination of dominant alleles and complete fixation of the recessive ones. It will select the dominant alleles and it will lead to the elimination of the dominant alleles. Thus, what we will be left with is recessive alleles. So, recessive alleles will be fixed. It means selection against dominance will be operating. So, selection against recessive alleles means it will be for dominant alleles. So selection against recessive traits and recessive alleles proceeds slower compared to the dominant alleles. Selection against dominant alleles operates at a faster rate, but selection against recessive alleles will operate at a slower rate, and it leads to the total elimination of the recessive gene. But recessive totally is not lost, it is many a times weak, because of which dominant allele will be stronger and is expressed, but the dominant allele it was removed. Then you have selection against homozygous. Selection against homozygous means that is for heterozygous. Okay, so the selective superiority of heterozygous will lead to equilibrium in which both the alleles in the population will be fixed. Now, selection against heterozygous means it will be for both homozygous. That means in this situation, both the alleles will be favored by selection. Both the alleles will be favored by the selection. So the natural selection may eliminate either of the allele, or either of the allele may be eliminated by your genetic drift, because genetic drift and natural selection works together. So I will repeat the last two. Selection against homozygous. Selection against homozygous means it is for heterozygous. For heterozygous, that means the selective superiority of heterozygous leads to equilibrium. Okay, that means you will select the heterozygous in which both the alleles will be fixed. Both the heterozygous, A and capital A and small a, they are heterozygous. So both will be selected and both will be fixed. But selection against heterozygous means it is for homozygous. In this situation, both the alleles will be favored by selection. Either it can be eliminated or it can be selected. Elimination can be by your genetic. Next is your selection for multi-gene trait. Multi means many. So in case of multi-genes, selection operates against each pair. In case of single gene, it was one gene. Okay, one gene, dominant allele, one allele. Okay, homozygous, one, heterozygous, one. Even if it is capital A, small a, either one will be expressed. Okay, so it is once. That is why it is selection for single gene traits. Now, selection for multi-gene traits In case of multi-genes, selection operates against each pair. The genes which do not contribute to any phenotype expressions will not be selected. So if the genes that will be contributing for the phenotype expression, they will only be selected, the complete pair, and they will be. So natural selection and evolution. So natural selection, nature will select the allele which allele it will select, it will create a variation, and that particular will create a evolution. Okay, so when nature will be selecting, definitely it will select the fit one. So natural selection always selects the fit one, that is survival of the fittest. It is always directional, it will flow in. Natural selection is always directional. It can lead to decrease, or it can either select or it can either eliminate. So it can decrease or increase the allele frequency, but it will always be directional. It is against, natural selection is against Hardy-Wigner equilibrium, because Hardy-Wigner said that there will be no selection, but it is against Hardy-Wigner equilibrium. That is how your natural selection is leading to evolution. One allele gives individual a reproductive advantage over the other individuals, because it will create the, or it will choose the better adapted one, which will be having the gene which will be having better adaptation. It will select that one. Better adaptation, better reproduction, or more is the reproductive rate. So definitely that allele will be a reproductive advantage. And the alleles which allows the greatest reproductive success increase in the frequency. Other alleles will be definitely there. So this is how your natural selection and migration is helping in the evolution. Okay, they are the forces which will lead to evolution. Thank you.